Okay, this is a section 3.8, number 23. And what we want to do is we want to find an equation for the tangent line to the graph of y at the indicated point. So that equation y is the inverse secant of x, and it's going to be at the point x equals 2. We want the equation of the tangent line. Well, first of all, we have to find, I guess, the slope first. We also have to find the y, the x and y, so we have both coordinates of the point of tangency. So first of all, I take the derivative of this, and we know by our formula the derivative of the inverse secant of x, just straight x, is just 1 over the absolute value of x, times the square root of x squared minus 1. That's in the denominator. And all we have to do is substitute 2 in to find the slope when x is 2. That's going to be the point of tangency. And that's going to be 1 over the absolute value of 2 times the square root of 2 squared minus 1. Absolute value of 2 is just 2. 2 squared is 4 minus 1 is 3. So I've got 1 over 2 times the square root of 3. And I just pop that in the calculator, and you get 0.289. So you should verify that with your calculator if you haven't already done that. And then we have to take the well, that's the slope of the tangent line, 0.289. Now, I left all the, digits, these significant digits in my calculator, and I just put it in alphabet A just to, I stored it and just used the large number when I did all my calculations, but they came out all right even if you round it off. So now I've got to find the y that goes with this x. So I have to put y in here, or x in here, to find out the y value. So I have both coordinates of my point of tangency. So I'm going to put 2 in to find out what y is. So y is the inverse secant of 2. And that's the same thing as the cosine of 1/2. And those are these calculator conversion identities on page 169. So make sure you see page 169. Page 169. And they give you those calculator conversion identities, and they have that the secant, you can see these right over here. I'll just show you this right now so you can see that. So those are those identities, and that tells you that the inverse secant equals the inverse cosine of 1 over x, so we have to take the reciprocal. We don't have an inverse secant, so we have to use these identities when we're looking these up. And the cotangent is the tricky one, so you have to make sure inverse cotangent is the tricky one, so make sure you take a look at those. And all I do is take the inverse cotangent of 1 over 2, which is 1/2, and then we get 1.047. So that's my y value. So this is my slope, given by the derivative evaluated at 2. And this is my x value, which was given. This is my y value when I put the x value back into the function. And we just use our point slope form. Y minus y1 equals m times x minus x1. So y minus y1, this is our y1, equals m times x minus x1. We multiply this out. 0.289x. And if I multiply this by 2, I got 0.577 minus negative. And then I added the 1.047 to both sides. And then we simplify these. This 1.047 minus 0.577 ends up being approximately 0.470. And this is your slope. So that's the equation of your tangent line. So just some calculations using the inverse functions, inverse trig functions.